All right, 9.3, some more hypothesis tests. Mean annual earnings of all family practitioners in the U.S. So the population mean. In a sample of 55 family practitioners in LA, had a sample mean, 192,340, and a sample standard deviation of 42,387. That's a 3. Does it conclude that the mean salary for practitioners is greater? So our alternative is we think it's greater, to the right of more than. And the null is always the population mean is equal to what it is. Makes this a right-tailed test. Our t-test stat. Sample mean minus the population mean divided by a sample standard deviation divided by the square root of our sample size. Get my numerator first. Divided by the whole denominator in parentheses. I'm rounding my t-test statistic to 3 decimal places, so it'll go up to 4. So it's a right-tailed test. My critical t-value is, the area is all in one, level of significance is in one tail. It's going to be positive, and it's right off the table. My degrees of freedom is 1 less than the sample size, so it's 54 here. So 0.05 is the 1, 2, 3, 4th column. Now 54 is not on the table, so I go to 50. So it's positive 1.676. Is my test statistic in the critical area? Is it greater than 1.676? And yes, it is. So because it falls in the red zone, the critical area, we reject the null, and we can support our claim. Doctors in LA make more money. All right, let's do another test. The mean annual tuition and fees for a sample of 14 private colleges, sample size 14. The mean tuition and fees, sample mean, with a standard deviation. That means it's the sample standard deviation. Is it reasonable to assume that the population, we assume that the population is approximately normal. Can we conclude that the mean tuition and fees for private institutions, in California differs from 35,000? That makes that the population mean. So our null is the population mean equals 35,000. Alternative is going to be that, hey, we think it's different from that, not equal to, which makes it a two-tailed test. Okay, we're going to calculate our t-test statistic. That's an n, Sample mean, population mean, sample standard deviation, square root of the sample size. Get my numerator. Divided by parentheses 7,200. So let's go out to 3 decimal places. 7 for our t-test statistic. So we have a two-tailed test. So we have both positive and negative critical t-value. And I have to split my level of significance between the two tails. My sample size was 14, so my degrees of freedom is 13. Making sure that we're in the right, oh no, this one. I have to go 0.005 and down to 13. It will be 3.012. Both positive and negative. Does our test statistic make it into the red zone? No way, not even close. It's about time we didn't make it there. There's our test stat. It did not make it in the critical area. So we fail to reject the null. They're right. We're wrong. If we don't make it in the critical area, we fail to reject them. We do not have enough evidence. To support our claim.